The Karoo is a vast and semi-arid region within the central hinterland of South Africa. It derives its name from the Khoi language, that being the language of South Africa's first peoples, the Khoi San. The Khoi who lived in the Karoo were the first people to live in the Karoo, referred to it in their language as Karoo, a dry and hard place. That description of the Karoo remains relevant today to anybody who has traveled throughout the Karoo. In addition, the Karoo remains a relatively pristine space with significant natural and cultural heritage sites scattered across its vast area. This story of the Karoo has been foretold across the millennia, starting with Bushman rock paintings that we can see today, as well as subsequent stories covered in the many literary works that were set in the Karoo by many well-known authors in South Africa. However, today, that story remains interwoven in the broader story of South Africa moving into the future. A new story is unfolding in the Karoo over the last 10 years or so, that being the story of proposed shale gas development within the Karoo Basin. This proposal has generated significant controversy, not just within the Karoo but across the country. That has actually spurred a nationwide debate, which we have come to know as the Great Karoo Shale Gas Debate. This debate has emerged primarily as a result of reports of incidences of contamination and pollution of groundwater wells within the United States, particularly in areas within the US where shale gas development has occurred. In responding to this, and in ensuring that there's sufficient understanding and knowledge of the Karoo prior to any shale gas development in the basin, the African Earth Observatory Network at the Nelson Mandela University, in partnership with the Eastern Cape Provincial Government, in 2014 undertook a baseline study of the Karoo prior to any shale gas exploration or mining. The rationale for conducting this baseline study really is to gain an understanding of the receiving environment prior to any exploration and mining. Internationally, this thinking around shale gas has gained significant acceptance. However, for us in the Karoo, this study is informed by four key priorities, that being water, the deep subsurface, the environment, and the people living in the Karoo. What follows is the story of this baseline, which we conducted in the Karoo.
So the main aim of the groundwater baseline is to hydrochemically characterize the groundwater aquifers in the Karoo and specifically our study area. The challenge we had was, because it's such a vast area, is to get a high enough resolution of samples to accurately characterize the hydrochemistry in the study area. I'm proud to say that we have covered 750 sites, which includes boreholes and springs. Those sites have all been submitted to the laboratory where the major cation and anion trace elements are being analyzed. Those elements will be spatially interpolated to eventually represent the baseline across our study area. It is also the plan that those sites will form the monitoring network should hydraulic fracturing take place.
So the technique is basically measuring the ambient noise of surroundings. So what we do is we install three components in the field, in the Karoo Basin. So what we do is we dig a 30 centimeter hole, and we install a container, and the container just to protect the equipment from animals and from different weather conditions. Where in the container is a geophone, so data cube and a battery, and a GPS for synchronization between the stations. So we have typically between 15 and 20 stations that we install in the Karoo, and we leave it there for about 4 to 6 weeks to measure ambient noise of the surrounding. The seismicity gives us information about the natural movement of the Karoo subsurface. The seismicity map is important since we can use it to compare and contrast the Earth's natural movement before and after hydraulic fracturing.
We are here in the core shed to study the Karoo Basin stratigraphy. We're looking at deep boreholes, which are more than several kilometers long. And this study involves describing every single rock layer and make units. And this is very important to understand the Karoo Basin. So for this study, Thomas is collecting dorite sample to date. Vuvu, she's looking at contact metamorphism around this dorite, which intruded the basin at around 183 million years ago. And Tibatso is collecting and looking at some shale samples to study the geochemistry. Together, we are learning about some of the most classic geology of South Africa.
So using our state-of-the-art methane isotope analyzer, we've been able to do quite a bit of research in the southern Karoo Basin where we've been able to identify methane leakages from deep wells, boreholes that were drilled below 3 kilometers, as well as shallow boreholes and thermal springs. So using the isotopic signature, we're able to differentiate whether the methane's coming from the layer where they're possibly wanting to do hydraulic fracturing, or whether it's shallowly derived. And also we're able to map baseline methane concentrations of our study area while we're driving certain routes, and we've noticed the influence that agriculture is having on the methane released into the atmosphere.
Now, the reason we're studying termite mound distributions around the Karoo is because they are what we call ecosystem engineers. Termite mounds are one of the first organisms that actually detect a change in the environment. The reason they are able to detect a change in the environment is because as much as they stay on the surface, they also go on the subsurface. With termite mounds, they look at the chemistry of the soil. So if the chemistry of the soil changes, it does affect their distributions. Or if the water becomes less in terms of the water tables, or the water content changes, or there's a contamination in the water, it does affect the distribution of termite mounds. If the distribution patterns deviate from the model that we're going to predict or that you're going to come up with, then perhaps that could be a signal as to that there is something that has changed in the environment, which is why now the termite mound distributions are deviating from the pattern that we have predicted.
I've been doing a bit of work with some of the airborne systems. So one of those is an unmanned aerial vehicle, which is a UAV. It's essentially a small aircraft which is flown while the pilot's still standing or sitting on the ground. So there's nobody in the thing that's actually flying. And they come in a variety of shapes and sizes, and what most of them have in common is that they are a lot cheaper to operate than a full-sized aircraft. One of the things that they're particularly good at is once you start hanging various cameras and things onto the bottom of them, you can get a picture that's a bit better than, because you're now able to get above whatever's in the way, you get an aerial view, and that gives you a better option. You can see certain things more clearly. So if you're looking at, for example, a dam, and you're looking at a dam at ground level, you can't really see how big it is. Once you fly up a little bit, and you can get an idea of how big that dam is by looking at how much of an area it covers. What we're wanting to use this sort of technology for is, because of those lower operating costs, we can fly over the same area more regularly than we could if we had a full-sized aircraft, because it's cheaper to run, which means that we can look for changes in the visual landscape as things are happening. So if we fly over and we see a certain number of plants in an area, and then we can fly over again in 3 months and we can see how that number of plants or the health of those plants is changing. And depending on what type of sensors we put on there, there's other things that we could look at. So if you allow for infrared visuals, for example, that can tell you other information about the health of plants in the area or things like that. So the same sort of things that you could use satellites for, you can use this for, but for much smaller areas and at much higher resolutions.
My research is focusing on capacity building of the local community within Cradock, and local community mainly focusing on the young men and women of Cradock who are unemployed but who are willing and able to be part of scientific research. Because the overall purpose of the study is to capacitate the non-scientists to become part of scientific research, mainly focusing on groundwater monitoring in the light of potential shale gas exploration in Cradock.
Currently, I'm busy training some of the community members here in Cradock on how to conduct hydrocensus. And the hydrocensus basically just entails a collation of all the water resources on a specific property. In this case, we're dealing a lot with Karoo farmers. So currently I'm training them to do the hydrocensus. The hydrocensus then, they basically take all the measurements at all the boreholes, springs, dams, wherever the farmer they get their water resources from. And they train to conduct a proper sample and to send this to laboratories in the correct manner. We do in-field electrical conductivity measurements as well as temperature. The EC measurements gives them a first order idea of what the quality of the water is. So the aim is that these community members becomes the custodians of the water resources within the town and the surrounds, and hopefully take it further to set up their own businesses to do sampling of water and groundwater in general across the Karoo and the surrounds here.
I was part of the team who was responsible for establishing a baseline disease profile for the communities within Tarkastad and Cradock. We went into the townships and suburbs and conducted structured interviews with participants following a full physical examination. All the data that we gathered during these physical examinations and structured interviews was compiled in a report to give us the baseline data for the disease profile within these two towns. This will give us an opportunity to make causal links between hydraulic fracturing and the disease profile of the two towns should diseases be reported that is caused by the chemicals used in hydraulic fracturing.
The primary objective of my study was to explore the potential socio-economic conditions or impacts of shale gas development within the Karoo. Primary to the study, firstly, as part of the baseline, was to ensure that we have a detailed socio-economic baseline of the social and economic conditions prevailing across the Karoo. The Karoo being composed of various district municipalities and municipalities, all of them unique with their own challenges and their own specific socio and economic conditions. Secondly, it was important as part of the study also to understand that connection between perception, public participation, and the level of information sharing within and amongst the people of the Karoo. In doing this, it was important for me to spend time with people in the Karoo, to hear and to understand really what people were thinking and what they were feeling on the ground. To do this, I undertook numerous interviews in the Karoo with stakeholders as far apart as farmers, ordinary community members as well as government officials located in Pretoria and within the provinces. I also undertook a number of focus groups with ordinary people in the Karoo from the various ward committees as well as with farmers within organized agriculture as well as local government stakeholders. It was important to do this so that we have a clear understanding of what these potential challenges might be, but more importantly, what the mitigating actions have to be in responding to these potential risks.